Hi, you guys. This is today's math hack. I'm Linda Hatch with Help with Online Math, and I want to come on and just give you a nice little math hack that I utilize for when my students are multiplying polynomials like this. So let's say we have a polynomial. We're multiplying. And specifically, you can use this whether you're doing a binomial times a binomial or a binomial times a trinomial. It does not really matter. So let's say that we have something like this, because all we're dealing with is polynomial multiplication. Okay, so I'm going to move this up out of the way if it will let me. Thank you. And I'm going to utilize this particular problem that you probably have seen many, many times when you're dealing with it in either Algebra 1 or college math or anything like this. So this is example 1. And let's say we have a simple binomial like this. Now, here's the trick, okay? First of all, look to see how many terms you have. You have 2 terms here. You have 2 terms here. So what is 2 times 2? 2 times 2 is 4 all day long and twice on Sunday. So what we're going to do is we're going to make ourselves a little square. And in that square, I'm going to have 4 cells. Okay, and I'm going to put those binomial terms right up here, including their signs along the top and the sides, okay? And now we're going to just multiply. So this is a visual form of the distributive property. So we're going to say x times x, of course, is x squared. X times 2 is 2x. 3 times x is 3x. Do y'all see what I did? I'm filling it in and just multiplying. 3 times 2 is, of course, 6. Okay. Now, here's what the magic happens. As long as these are put in what we call descending order, in other words, you have your highest power of x first, this term in the upper left is going to be your leading term in your polynomial. Okay. Along your diagonals, these are going to combine in some way. They're either going to add or subtract. So 3 and 2, remember we're adding because we're combining, that'll give you 5x. And then the one in the lower left should be your constant or your last term. And that's it. Okay, let's do another one. And it doesn't matter if you have, I'm going to do another one with like signs. Then we're going to do one with different signs, okay? So you can see the pattern, all right? Remember, got 2 terms here, 2 terms here. 2 times 2 is 4, because I have 2 terms and 2 terms, okay? So I'm going to make myself a nice little box that has 4 cells in it. Okay, and I'm going to place my problems right here. Okay, so I have x times x is going to be x squared, x times 6, that's 6x. And since that's positive, that's why that's a positive 6x. 8 times x is 8x. 8 times 6 is 48. We're going to do the same thing. We're going to write our first term, which is x squared, along our diagonals. They're going to combine. And then we're going to put our constant term last. That's it. Okay. Now, you're probably wondering, well, what do I do when I have to, different signs? Let's do one with different signs. And I'm going to clear this real quickly so that you get the gist of the pattern. So I've got different signs. So I'm going to do x minus 1, x minus 4. Okay. Here again, two terms, making ourselves a box. We're going to have 4 cells in our box because we have 4 terms. The number of terms matches the number of cells in our box. So we're going to put our x, and we're going to take that sign with it, that -1, x, and a minus or negative, however way you want to call it, plus a negative or minus. It's the same thing. And by the way, it does not matter if I had put x minus 1 here and x minus 4 there, it would not have mattered. Why? Don't forget, multiplication is commutative. Okay? Does not matter what order we multiply in. So x times x is x squared, x times -1, -1x, -4 times x is -4x, and -4 times -1, a negative times a negative is a positive. Okay, so now I'm going to write my first term first. Right along here, I have -5x and then +4. Okay, so the pattern is the same, even if we have the same signs, if it's positive or negative. Now let's look at one where we have different signs. So I'll say x. I'm going to do the same one, but I'm going to change the sign. Okay. All right, so now heads up, don't you mess up those signs. I was always prone to making sign errors. I do not know why, but I always would make a sign boo-boo, okay? So if you know that's your weakness, you pay close attention when you're working with sign numbers. So I've got x and x is x squared. X times -1 is -1x. 4 times x is 4x. And 4 times -1 is -4. All right. So we write our leading term first. Now along our diagonals, this time I'm not going to add. I'm going to subtract. Why? Because I have different signs. So I'm going to subtract and take the sign of the number with the largest absolute value. So 4x minus 1x will give you plus 3x and then minus 4. Okay. All right. Same process with different signs. So now let's do another one with different signs. Let's do another one with different signs. Okay. I always was a teacher that gave a lot of examples, and that is because I know that people need them. Okay. So let's do x plus 6, x minus 8. Same thing. We've got two terms. And in another video, I'll show you what to do when you have a binomial times a trinomial, okay? But this time we're just dealing strictly with our binomials, okay? So I'm drawing a box or a square, however you want to call it, with 4 cells in it, putting my sign numbers, sign terms at the tops and the sides, okay? Then I'm going to multiply. X times x is x squared. X times 6, 6x. -8 times x is -8x. -8 times +6 is -48. All right. This is my first term, which is x squared. I'm going to combine along my diagonals. So I'll be subtracting since I have unlike signs, and I take the side of the number that has the largest absolute value. So that would be the 8, the negative 8. So that will give me negative 2x minus 48. Okay. All right. Hope this helps you. This has been today's math hack, and we are multiplying binomials. Hope you enjoyed that. Follow me on social media. Okay. I am Help with Online Math. See you soon. Thanks. Bye.